So for today, we have a quick discussion on Hibernate tools, which actually is at this point not relevant. We will be using tools for uh, reverse engineering our code and working with mappings on pre-built editors later on in our one of our modules. For now, we will stick to the very basics. We will use Eclipse and the basic Hibernate configuration option, and we will use just the plain drivers provided by vendors to connect. And apart from the tools, there will be some additional discussion on configurations, and then we will be configuring a model class using one of the two options, actually both the options, annotation and the XML way. So moving on, so in the last module, which was more conceptual, we did some discussion on what JPA is. We had some very basic recap of RDBMS concepts, and then we went on to discuss the very basic problem that an ORM is geared to solve, as in what is the need for an ORM and why and where it fits in our application architecture. And we also looked at how and what all objects are involved within Hibernate, what all artifacts are there which enable us to use Hibernate. We also had a very quick discussion of the model states before persistent objects are saved, and what is the life cycle they follow. So moving on, today we'll be talking more hands-on. So Hibernate tools is actually a set of plugins that the Hibernate team provides for us to easily use Hibernate, and there are some facilities that are inbuilt in the tool in the plugin tool set that let you easily start developing Hibernate specific code. So essentially, in a situation where you already have a database schema with all the tables and everything built, and you want to see how it will look if you coded all the corresponding Java objects against those tables, then Hibernate tools provides a very useful reverse engineering tool to do that. And along with that, it has support for editors that can help you easily code Hibernate configuration or Hibernate mapping files. So it lets you, it gives you an autocomplete facility. It links it with your code, and then there are some development wizards that can quickly get you started on Hibernate. It's very convenient once you know what's happening behind the scenes, so that you can quickly create everything and just concentrate on your business logic. So there are three kinds of tools that are given to us. One of them is the mapping editor. So if you're creating your mapping files, XML files, then it lets you do auto completion after connecting to your Java model classes. So it becomes really convenient. You have all your classes already connected. You just have to type in, and then it completes it for you. So along with that editor facility, there is a console that that is able to give you a visual view of your model and how each persistent class is connected to the other, and then it also helps you quickly execute HQLs. So SQL is something that Hibernate gives you as an abstract overall SQLs. It actually translates into an SQL, but that translation happens factoring in the specific dialect for your vendor. So you have just one single set of instructions in an SQL that you can use, and Hibernate does all the specifics related to the vendor. So apart from that, as I said, there are reverse engineering tools. You could create your whole model hierarchy from your existing database schema, and there are some other tools as well that aid in building and deploying your application. At this point, we will not be going further into how tools can be used, but it's a facility that's going to be very convenient and handy when we start using Hibernate for more serious projects. So any questions about that? Okay, so moving on. So first thing you'll be doing to get started with Hibernate is downloading a Hibernate distribution. The latest version is actually 4.3.8 final, which I was working on yesterday. It's talking about 4.3.7 out here, so probably when this was written, they were still on 4.3.7. The link is, you can easily Google, find the link. It's hibernate.org, which holds all the downloads, releases, and news links related to Hibernate. Yeah, so as we had done yesterday, we need to ensure that all the necessary libraries that are published by Hibernate are on the Java class path to be able to use it. And there are some prerequisites, some other dependencies that Hibernate needs but does not ship with itself. So these can be downloaded from these locations. So it's possible that the versions and the actual dependency has changed with 4.3.8. What I downloaded yesterday had a complete shipment. I didn't have to download anything extra. I would suggest you guys can also do the same. Okay, so it's talking about configuration. Hibernate configuration is something we will go into as hands-on exercise. Yeah, it's talking about the basic configuration that's needed to get Hibernate up and running. Something that we'll go into very quickly. So there are some basic attributes that you configure. One of them is the Hibernate configuration, which holds. Okay, I think the question is 1 second. So the configuration file holds some very basic configuration that are required for connecting to the database, plus there are lots of other configurations related to Hibernate runtime and transactions and everything. We will go into the list of configurations that can be made out here. You can also link to a property file that holds the basic configurations, pick it up from there. And then there is, so we'll go into what an entity resolver is, but essentially you can configure your own entity resolver instead of the one provided by Hibernate uh, by default. And the utility for that is if your entity mapping needs to be customized in some way according to your requirement, then you can do that customization in your own implementation. So at this point, I'm not going to talk more about it. We will discuss that once we have discussions on more in-depth mapping. And along with that, you can have your own naming strategy. So by naming strategy, what we mean is Hibernate maps your entities to database column names and table names directly. So, and if you want any customizations on that naming strategy, so for example, if your Java class is student and you want your tables to be named as Edureka _ student, then this strategy can be defined in your naming strategy customization that you will have to implement in a class that that is going to implement naming strategy interface. So along with that, there is something called a file set, which is actually an ant build set, which is used for collecting all the mapping files and running ant jobs on them. We will not be using ant, it's an old build tool. We will stick to, at this point, we'll stick to how Eclipse is used for building your projects. So this diagram is again talking about the three object states. We've seen how we create a transient object using the new operator or any business logic that actually gives you an instance of your object. This. So yeah, this is something that we had already discussed. A new operator creates your transient object, allocates it memory, and you know, with your business processing, your object gets all the values, all the fields set, and then with the save or update call on the session, passing it the transient object, the object becomes persistent. And once your session is complete, the object is detached. These are the three states. It's also possible to remove an object from the session without actually ensuring or without actually needing the session to be over. So there are methods like evict, which can, you know, remove your object from the session. And then obviously all of them can be garbage collected. Okay, it's talking about the same thing again. The transient object is something that your business logic creates, and it intends to save it. So during the time a session does not get a reference to the transient object, it stays transient. None of the states that are maintained in the object are going to be persisted even when they are updated, or even when the object is deleted. It will not be updated in the database because there actually is no mapping between the database rows and the actual object that you've created. And calling save on the Hibernate session is what ensures that transient object moves from the transient state to the persistent state. We had actually gone over this in our last module as well. From the persistent state, once the session does its database interaction and closes, the object moves to a detached state. So what is interesting is that it's possible to reattach this detached object, and the same mapping to the same row can be achieved for this object which was there when it was in the persistent state. So moving on from the states discussion, excuse me. So we did talk about JPA and what it means and how Hibernate is actually one of the vendors that provides an implementation for JPA specs. And this diagram is again a different version of a couple of diagrams that we've seen earlier as well. A session factory which is created from a database configuration, and then sessions which are retrieved from session factory and deal with Java model objects, moving them from one state to the other. And the underlying APIs behind the scene for these transactions, for these artifacts, are the transaction and the query. So the transient state is where there is no ORM in the picture. Let's say you get a request for let's say a new user registration, and your business logic retrieves attributes like first name, last name, email address, and everything from the request, and creates your model object user, and it's just lying there as a reference that's been created one of the methods, and probably returned a method called create user returns a variable called user, and it's there in your service calls. Now this user object with an intention that it needs to be saved has to either be passed to your session, or with an intention that probably there is some validation failure. It could be garbage collected. If your business logic wants that if it fails validation, or any logic that you implement, then your business logic wants that it should not be saved. So it's called transient because it's possible that we might lose it, we might not need it, or it's possible that we could persist it. But at this point, any changes that you make to this user object before you actually call save on the session with a reference to this object are lost. So that is why it's called transient, because any changes that you're making, there is no contract with your ORM implementation that these changes should actually be persisted to the database, because Hibernate does not know the existence of this object unless its reference is passed to the session through one of those calls, which could be either update or save. Please let me know if you want more discussion on this. It's a very basic state that actually there are more discussions related to how detached and persistent states move from one to the other, and how we can use detached objects in longer running transactions. But a transient state is a very simple concept. It's called transient because it's not connected to a database. So Puneet, please let me know if you want more discussion on the transient one. We can go to the detached one if you're good with this.
Hello?
Yeah.
I'll read it myself after the session. If I will have any question, I'll ask next time.
Okay, sure.
At present, it's clear.
Okay, great. So just a quick, just a quick recap of the detached state. Detached state is, an object coming out of the persistent state and still be available as a candidate for being reattached to the session for updates to the database. So let's say if that user registration has been persisted, and then there is a link on let's say the UI that says edit profile, and once that edit profile is done, a request is received, and the user object changes its state. Let's say it changes the email address. Then the way you want to actually update it in the database is uh, the detached user object can be reattached to a session, and the moment that reattachment happens, the update to the state that's there in the user object is actually immediately communicated to a database. So there are APIs to reattach to a session. We'll go over those. But at this point, reattachment just ensures that that same association is rebuilt. So any updates to the detached state are before it came out of persisted state. Any changes that you're making to that detached state are actually moved again back to the database and updated.
If we have created any instance, once it is closed, won't it get garbage collected?
Yeah, so garbage collection is something that your JVM will do once references are lost. Detached state is something that just means that your object is removed from the session. It's still there. There is still a reference in your business logic for that detached state object. It's just that it's not connected to a session. So detached state does not mean candidate for garbage collection. Garbage collection would mean when there are no references.
Okay.
So moving on, again this is again a restructuring of the diagram that we've seen a couple of times. There is a host application, and then JPA specs provide some certain APIs which are presented to the business layer, and then an ORM vendor comes into picture which actually does implementation of those APIs, which in our case is Hibernate, and then the actual database interaction happens. So we've seen this as well. What all features does JPA provide for us? Okay, so annotations is the reason why I'm discussing annotations here is because we will be using annotations as one of the ways in which we can carry out our mapping and configuration. Otherwise, annotations is something that we all use post Java 1.4 version. Annotations are being used in almost all frameworks, and with core Java J2SE versions as well. So I'm pretty sure that everyone must have used annotations for some or the other requirement in the projects. Please stop me if that is not true. So this slide is just telling you why it's called annotations, because it's actually commenting or adding metadata to your core discussion in context. Annotations in Java terms is actually annotating your classes or methods or fields with extra information so that they can have some context in which they are being used. So for example, we had an annotation like override, which is usually applied on methods to indicate that they are being overridden from a superclass. So annotations in Hibernate are provided in the JPA package Java X persistence. Annotations, the way they're explaining is more specific to how we use it in Java in general, I'm pretty sure that everyone's used annotations in Java language. Uh, Annotations are important for Hibernate because annotations along with XML are two ways in which we can provide configuration to Hibernate so that it can do its mapping and connectivity operations. For specification uniformity purpose, all annotations are within a package called Java X Persistence. Uh, it's something that all vendors are supposed to follow when they are JPA2 compliant. So other things that they're mentioning are essentially related to why annotations are good because you don't have to take your configuration out of your Java code and it's declarative. So there'll be annotations like entity ID table that we'll be talking about when we'll be creating our mapping. Okay, is there a question there? No. Okay. All right, moving on. So again, this is specific to annotations. That does not have much relevance in terms of Hibernate. Okay, so now we're discussing the Hibernate configuration file. It's possible to add your configuration either in the XML file that we had seen yesterday, or it's possible to do it programmatically as well. Ideally, it's always done in a configuration file because it's necessary to keep it separate from the code. That's an ideal practice. I will go into each of these properties as I show you the configuration file that I've created for the project. Again, this is talking about how annotations will be used for persistent class mappings. I will show you that in the project that I've created. And then along with all the Hibernate specific libraries, we will have to add the driver library of your specific database provider. For Oracle, it's OJDBC14.jar. I'll be using HSQL and MySQL. I will show you which connectors or driver files need to be added for both. So these annotations are what we use for mapping your model class to your table columns. Entity is what is used to describe your whole class as an entity. It's a class level annotation, and table annotation is able to give you what table should this entity be saved to. So if you don't have the table annotation, then the name of the class is what is used to create the tables by Hibernate. And then ID annotation is something that identifies a field as a primary key, and with each field you have the column that that a particular field should be saved to or should be mapped to in your database. I will show you how each of these is used in an actual project very shortly. So we saw this file yesterday. We created an HSQL connection and we were supplying these properties to our configuration file. We'll be doing the same for MySQL today, and we'll be discussing in more detail some of the properties. Okay, so the file is called Hibernate Config XML. So it's possible to rename this file to something else. I'll show you how that is done. So obviously it's moved to the detached state. Yeah, so we can use JPA annotations as well. Okay, so it's talking about configuration and how XML is used to configure various applications, like your Ant build script is written in XML, and Tomcat has a lot of configuration artifacts that are written in XML. Your servlets have their reference in the deployment descriptor, which is written in XML. And then for some reason it's also talking about XML based Java APIs which are used for parsing and creating documents from XML. So Java Doclet is one of the EJB specific uh, deployment descriptor languages not used anymore. Not a very useful or relevant slide for our discussion. Yeah, so a mapping file has a bunch of things. The first thing is how a particular object maps to a particular table, and what all columns are mapping to what all fields, and there are other detailed configurations that you make in terms of, let's say, how do you want to calculate the value of your primary key, or how you want to calculate the fetching strategy. Both of these things are something we will discuss in our next module when we will be talking about mapping in detail. Okay, now so at this point, let me reiterate that. So we are talking about two configurations out here. One is the configuration that talks about features like the provider driver, uh, username and password for your database, SQL properties, certain Hibernate runtime properties that you will be using, which are these configurations are not related to mapping. They are related to how Hibernate is going to run, which database it's going to connect to. So this is the mapping that resides in the configuration file that we've been talking about in a couple of slides earlier. The other configuration is the actual mapping that your Java objects have to specific tables and columns. So both of these can be either done programmatically or they could be done using XML. So out here, the mapping we're talking about is the actual class to table mapping. So For that mapping, you have these tags that you use. I will be showing you how to use these tags inside a separate mapping file. Uh, a parallel mapping can be done using annotations, something we just talked about with the entity and column and table annotations that we just seen in 3 slides back. Okay, so Hibernate mapping file is used for mapping the Java objects to particular tables, and there are various tags that are used for the actual mapping. Uh, there is the DTD declaration. So each Hibernate configuration that is implemented via XML has a backing DTD. I'm assuming that we know what DTDs are. They are actually description of the structure that XML is going to be in. And then there is for your mapping, it's all enclosed in something called Hibernate mapping, within which first element would be the class element that you are intending to map, and then there are actual properties, individual Java object properties that are mapped to particular columns, uh, and there are attributes, whether that property is not null or unique, that are also mapped out here, along with which there are some association and collections mapping that are done, something we will go into later. So the important tags that we just spoke about, the class tag, the ID tag, there are some parallels. There are all parallels for these exist in the annotation world as well. So we've also talked about session factory in our last discussion. The session factory represents a database, and it's just built once, and the way it's built is that none of its attributes change during the life cycle of the application, so it's thread safe. There is a consistent value set for one particular life cycle of the session factory. So as we saw for HS2, there is a similar configuration for something called Derby, which is again a database implemented in Java. We'll see, we've seen this mapping being done for HSQL already. Something similar can be done for MySQL. In fact, identical entries apart from the dialect and the URL exist for different vendors.